Hello, welcome back to Math 7 with Mr. Passon. Today we are continuing our unit on probability. This is Unit 11, Lesson 6, Dependent Events. And now a dependent event is when the outcome of one event impacts the likelihood of another. Then it is a dependent event. So if the probability changes because of the first result, it is dependent. Now we're going to just read these situations and think about whether they should be dependent. Flipping two coins, resulting in one landing on heads, that's the first event, and one landing on tails, that is independent. The outcome of the first event will not affect the outcome of the second. Alright? The captain of the football team is selected, and then a co-captain is selected. Well, the person who was picked as captain cannot be co-captain, so his probability of being co-captain definitely changed. This is dependent. Okay? You draw a joker from a deck of cards, and then you draw an ace. Well, just the fact that you drew that joker changes the makeup of the cards. There's now less cards, and that ace is more likely to have been picked than if the joker was in there as well. So that is dependent. Dependent. There we go. Alright. You draw a queen from a deck of cards, replace it, and then draw a 10. Well, by replacing it, this deck is in the exact same state it was before, meaning all mixed up and all cards equally likely, so that one is independent. Alright, last one, and I'm going to just take the text size down this a bit, that way that fits. A coin is flipped and a number cubed is rolled. The outcome of the coin is not going to affect the cube. The outcome of the cube is not going to affect the coin. Those are independent. Alright, now last time we learned that the probability of A and B happening was the probability of A. I'm just going to move this over a little bit so the multiplication is right there in the middle, times the probability of B. And again, actually just move it down so the multiplication is right there. Oh. Move this one down. So the probability of A times the probability of B. Now for dependent probability, you'll see that it is a little bit longer here. And it's still, the first part is the probability of A times the probability, let me go ahead and put it over here, the probability of B if, and this vertical line is sort of going to be an if statement for it, if A happens. Alright, so this fraction, last time we were saying the fraction would always be the same. This time the fraction might change a little bit. It's still a multiplication. It's just a multiplication of a slightly different fraction. Now we've got a combination of problems that are dependent and independent because it's more important that you can figure out what you're supposed to do and what the situation is. So we're going to read these and we're going to see if we can figure it out. I believe both of those are dependent. So, Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that he selects a bone and then a ball? Well, the probability that he selects a bone, and there's 1, 2, 3, 4, 5, 6, 7 items. 3 are bones. So that's 3 out of 7 for the bone. And then 1, 2, let's go ahead and cross out one of the bones though, because we can't pick that anymore because he didn't put it back. Alright, so now let's think about how many balls there are. Well, there's 2 out of 1, 2, 3, 4, 5, 6 items. 2 out of 6. Again, we can simplify that. That's 1/3. That's going to make our answer go a little bit smoother. So we have 3 over 21, which is 1 over 7. Alright, now if you're not sure how I got to the simplification, Go ahead and multiply it out, pause the video, figure it out, ask somebody, and make sure you have that down, because simplifying is something that we kind of expect you to know. And if you don't know, I mean, I understand, don't practice all the time, but you're going to have to make sure you get caught up. Alright, let's go ahead and look at this next one. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie chooses a polka dot candle both times? Well, there's one polka dot candle out of 1, 2, 3, 4, 5. Two polka dot candles out of 5, so that's 2 out of 5. Times, well, now we're going to take out one of those candles, those polka dot candles, and we've got 1 out of 4. So our probability is 2 out of 20, which is 1 out of 10. Alright, so that was the first page. Let's go ahead and look at page 2. Oh, I accidentally went too far. Alright, so we're going to want to look at this picture. What is the probability of selecting a top and then selecting a bottom? So a top is a shirt, and I only see one shirt, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 items. So the probability of selecting a top is 1 out of 16. Times, now if we take out that shirt, let's count the bottoms. I see 1, 2, 3, 4, 5 bottoms. 5 out of 15. Again, I can simplify that. That's 1 out of 16 times 1 out of 3. So we multiply the tops. That's 1 on top, and that's 48 on bottom. If you're not sure about the multiplication, stop, do it off to the side, double check, make sure I'm right. Alright, what is the probability of selecting a striped sock, replacing it, then selecting another striped sock? Note that we're replacing it, so this is the independent case this time. So we have 1, 2, 3, 4, 5 socks. So it's 5 out of 16 times 5 out of 16. The probability did not change because we put the sock back. So that is 25 out of, and again, 16 times 16. If you don't know it, pause the video, work it out. 25 out of 256. Now that is almost 25 out of 250, so that is very close to 1/10. It's a little bit less than 1/10. What is the probability of selecting a towel, replacing it, and then selecting another towel? Well, there's only one towel, so that's 1 out of 16 times, and again we replaced it, so there's still one towel in there, 1 out of 16. We already know 1 times 1 is 1, and we already worked out 16 times 16 is 256. What is the probability of selecting a skirt and a top, one choice after another? Well, the skirt, we've got 2 skirts, so that is 2 out of 16, and that is 1 out of 8, times, there's only one top, that's 1 out of 16, so times 1 out of 16. Right? We need to multiply that out. Oh! Did you catch my mistake? We're not replacing it. It's 1 out of 15 this time. We did not put the skirt back. Alright? So 1 times 1 is 1. And then 8 times 15 is 120. If you didn't know that, that's okay. But you should be able to work it out by practicing your multiplication. Last question. What is the probability of selecting a matching pair of solid socks, one choice after another? So there's 1, 2, 3, 4 solid socks. So we have 4 out of 16 times, now there's only 3 socks left, out of 15. So that is 1/4 times 1/5. We multiply the tops. 1 times 1 is 1. and then 4 times 5 is 20. Excellent. So we've gone through, we've practiced calculating. We had some independent ones in there that we had to figure out. We noticed that sometimes our numerator and our denominator changed because of what happened earlier. That is the result of it being a dependent event. Again, we have an assignment in ALEKS. Go ahead and check that out, practice it, and we will go on from there. Have a great day.